with implicit differentiation, how come d dx of y squared is equal to 2y times dy dx? Well, what does y even mean in implicit differentiation? Well, if you go back to algebra 2, do you remember seeing functions like y equals x squared plus 5x plus 4? You'd also see it written like this sometimes. F of x is equal to x squared plus 5x plus 4. Sometimes they'd use a different letter, or they just they'd use a different letter, so they might use G, and you'd see it like this. But y and f of x are the same thing. Y and g of x are the same thing. So we can say that y is a function of x. So when you see y in implicit differentiation, remember this: y is a function of x. So you can think of y as g of x. You can think of y as f of x. Right? Okay. So with that in mind, I'm going to call y g of x. You can name it f of x, but I'm going to call it g of x, and the reason why is because, you'll know later, but I'm going to say g of x is equal to y. Now, what does this turn into? It's going to turn into d dx of g of x squared. Okay. So you'll notice that there's a function inside of another function. So if we wanted to find d dx of this, what rule might we want to use? We might want to use chain rule. So this function involves squaring the input. So I'm gonna say f of x is x squared. We're squaring the inputs. Okay. So if I go over here, right? It's the same thing as asking for d dx of f of g of x. How come? Well, let's go back to this equation. If I change all the x's here to g of x, what do I get? I would get f of g of x is equal to g of x squared. So that's why this is the same as this. Now we can apply chain rule. So the derivative with respect to x of f of g of x is going to be f prime of g of x times g prime of x. Okay. Well, if f of x is equal to x squared, what's f prime? It would be 2x. So 2 times g of x. Okay. And g of x is y. Okay, so 2y times g prime of x. So if g of x is equal to y, well, g prime of x would be taking the derivative of y with respect to x. Right, another way to write this is dy dx. So in both cases, we're taking the derivative with respect to x. So g prime of x is dy dx. Okay, so I cleaned up all the steps just now. This is what we would turn in as a proof. Okay, so that's why d dx of y squared is equal to 2y dy dx. Now as practice, can you show why d dx of y cubed would be equal to 3y squared dy dx?